Hi, welcome. In this video, we will solve problem difference of k in an array asked by companies like Amazon, Microsoft, Google, etc.
Let's check out this problem. So before starting the problem statement, I want you all to go through this problem statement, pause the video and find out how output is coming from the input. So let's start. You are given a sorted list. Okay, this is very important, right? Sorted list, not an ordinary list, right? So we need to come up with some good idea observations. So sorted list of length n and a target difference k. Your task is to determine if there exist two distinct indices, not element, indices. That means there can be same elements, such that is I and j, such that I should not equals to j and ai minus aj equals to k. If such pair exists, print found. Otherwise, print not found. Okay. So let's start. So here this is simple, like you can say one test case, right? So this is our one test case, and here this is n equals to 7 and k equals to 5. So let's see how the output is coming from the input. I'm using this as an array. So I have elements, so 1, 2, 4, 6, 9, 11 and 13. And so can we get two different indices? So let me put the indexes 0, 1, 2, 3, 4, 5, 6. So we need to find two different indices I and j. I should not equals to j, such that ai minus aj equals to k. So I want 5, right? So here if we check 9 minus 4, we are getting 5. So we are getting two different indices, right? I and j, such that 9 minus 4 is equals to 5. Okay, and apart from this, 11 minus 6 is also 5. So I will say I am getting this pair. So yes, I will print found. Okay, and let's check this input. So I will simply copy this one and let me put the values 2, 4, 6, 8, 10, and the indices are 0, 1, 2, 3, 4. Here I want to find 7. So these all are even numbers. So even 10 minus 2 I will get 8, 8 minus 6 I will get 2. So I won't get 7, that's why it is not found. So I guess the input and output is clear, right? How we need to do it, that's a problem. So just let me tell you that this is not found. So let's start with the basics. Okay, so I will simply copy this one and let's move to the next screen. So first of all, let's start with the first approach, that is the brute force approach. Okay, so how we can find it? By using brute force one, because this is sure that we will get a guaranteed solution. So what I will do again, I will take one element and I will find the difference from rest of the elements. Then again I will take one element and I will find the difference from rest of the elements. Again and so on, we will eventually find one solution. So I will start by taking one pair, 1, 2, then let me do this 1, 2, and then 1, 4, 1, 6, and so on. Similarly, then I will find 2, 4, 2, 6, 2, 9, and so on. And eventually I will find 4, 6, then 4, 9, and I will get this pair. Right? So the same method, the brute force one that we discussed in our last video, and the time complexity will be big O of n square. So we need to find an optimized solution. So again, let's observe it. So I'll simply copy it and let's move to the next screen. So let's do our observation. So if we can sort this, okay, this is already sorted. So let's try to build a graph for it. So what I will do, I will simply make this for 1, this for 2, this for 3, sorry, this for 4, I guess. 2, 4, 6, 9, 11, and this will be for 13. Okay, and let me put the indexes here. So 0, 0, 1, 2, 3, 4, 5, 6, and the values are 1, 2, 4, 6, 9, 11, and 13. Again, the same observations. If I am moving here in this right direction, the value will increase, and if I am moving in down direction, the value will decrease. But here we don't need to find a sum, right? So I don't want to increase my sum or decrease my sum. I want to find a difference, right? And difference. So let's take the 2 pointers again, and the difference will be, let's suppose, ARR of R minus ARR of L, where this is my ARR, that is there. So here, how we can increase or decrease the difference? What do you think? If my right value is increase, if this value will increase and this value decrease, my difference will increase, right? Or if my right value will decrease and this value increase, my difference will decrease. Alright? So what we will do? We will use pointers in such a way that we can increase and decrease the difference. Let me tell you how. So I have used left pointer here, and right pointer I will put here just after it. Why? First of all, in the problem statement it was saying your I should not equals to j, so my 2 pointers L should not equals to R, right? So I am starting with R equals to 1, and what I will do, so I will calculate the difference, right? So let me just quickly construct it. So again, there are 3 possibilities, like your difference can be greater than k, or your difference can be less than k, or your difference can be equal to k. So here, what I will do, I will first calculate the difference, right? So let me just remove it so that there won't be any confusion. So here you can see the difference is right now 2 minus 1, that is 1, right? So let me put it here, that is difference is 1. So if I am moving my R, right, so the value will increase, this right value will increase, and my difference will increase. So if I am moving my right pointer, my difference will increase. So if my difference is less than, what should I do? I should increase the difference. So what I will do? I will do R plus plus. I will move my right pointer. And now suppose you're writing here something. Something like suppose here, right? So what is the difference right now? The difference is 11 minus 1, that is 10, right? And you want, what was the k, the previous question? K was 5. Let me put it here. N equals to 7, k equals to 5. So I want 5, I am getting difference more than k, right? Here. So what I will do? I will move left towards it. Because when I'm increasing L, right? When I'm increasing L, my difference will decrease, right? So what I will do L plus plus here. So we are using these two things, right? We are increasing left pointer, we are increasing right pointer. So if I am increasing my right pointer, my difference will increase. If I am increasing my left pointer, my difference will decrease. Or you can take a mod value of it. So even if you are doing ARR of L minus R, that is also possible, but for this you need to change some of the pointers. But this is the case right now. So if we are moving, so if the two pointers will be more close, the difference will be less. If the two pointers are more apart, the difference will be more. And if I am getting difference equals to k, I will simply say it found. Right? So this is our observation. We are getting one of these things. Right? Now let's see how we can use it. So I will simply copy this and paste it here, and let's start. So let me mention it. N we have 7, K we have 5, and we are using two pointers. So I will use L here, R here, or R here, L, R, difference, and the action. So my L is starting with 0, R is starting with 1. What is the difference right now? Difference, how we will calculate the difference? That is ARR of R, that is the right pointer minus left pointer. So difference is 2 minus 1, that is 1, right, which is less than 5, right? So I want to increase my difference. So what I will do? I will do R plus plus. So my R pointer will point to 2. So right now L is still 0, R is 2. Now what is the difference? 4 minus 1, that is 3. 3 which is less than again 5. So what I will do? I will again do R plus plus. I will move my right pointer. Now what is the difference? So first of all, let me move the right pointer. So now L is 0, R is at 3, and now what is the difference? 6 minus 1, 5, which is equals to 5, and I will simply say that found. But suppose if this is 0, just I am giving an observation here. Suppose this is 0, and now what is the difference will be? Just for to show you how left pointer will move. Okay. So now what is the difference will be? Difference will be 6, which is greater than k. That is, which is greater than 5. So now what will be your action? You want to decrease the difference. So what you will do? You will do L plus plus. So your L pointer will move here. Clear? So again, remember, whenever the difference is greater than k, what we will do? We will do L plus plus. If difference is less than k, we will do R plus plus. If difference equals to k, we will simply say found. So now you can see we observed two pointer technique in two ways. One was the opposite direction that we have checked. Opposite direction when L was at 0 and R was at n minus 1, and both pointers were moving towards each other. And this is the case of same direction. When L is at 0, R started with 1, right? It can be any number, right? It can be 0 also, it depends on the problem statement. And both pointers are moving like to the end of the array. Now let's observe what will be the stopping condition here. We know the starting condition in the same direction will be this, right? So if I say my start point is my L is equals to 0 and R equals to 1. But what will be my stopping condition? When I will stop. So if you check closely, your R pointer is moving in this direction, your L pointer is also moving in this direction. It may be possible that L and R will, like L crosses R, but then the difference will come out as negative, right? In some of the cases, maybe we want negative difference, but you can see if your r is moving towards, so by the two pointers, your r will be the first pointer to complete the boundary of the array, to reach the boundary of this array, right? So suppose if both pointer are at the same direction, okay, let me tell you. So suppose if my L is also here, so if L and R both are pointing to the same, so then the difference will be 6 minus 6, 0, right? And in some of the cases, maybe we want difference 0, but we don't want by the same element, right? So what we will do, we will exclude it and we will move R pointer again, because I want to increase the difference, right? If my difference is getting negative, then also I want to increase the difference. So no matter what it is, your R pointer is always be ahead with the left pointer, until and unless if there is a special case. So your R pointer is always ahead with this left pointer. So you can move your R pointer till this boundary condition, till this array limit. So the last condition here will, when array leads to the last element, then R equals to n minus 1. This will be my last point. And if it is getting greater than n minus 1, I should stop it. So I will say my stopping condition will be when my r is greater than n minus 1. Right? So now let's see how we can code this out and how this eventually work. So this should be approach for this problem. What we will do, we will simply check the differences. If difference is greater than k, L plus plus, difference less than k, R plus plus, and we will simply print if it exists. Same as true sum. So to check the solution of this video, to check the code of this video, you can watch the next video.